Module 1, Introduction to Algorithms. In our first module, I will give you 4 classes, organized in part A, B, C, D. 4 parts. Today, part A, first class. Explain the syllabus and understand problem solving. The first part, I like to explain the main part of the syllabus. The part, I need to give you a lot of details. For other basic information, I do not need to explain. So you can just see the syllabus. But for the homework assignments, I need to explain a lot of things. So let's start that part. The coursework, our coursework. First type of coursework, quizzes. Quizzes, I plan to give you about 6 quizzes, 6 total quizzes. Okay? Basically, each module, 1 quiz. 6 modules, 6 quizzes. Practice. I allow you to drop 2 lowest scores. So if for some reason you may not do well, don't worry. Drop 2 lowest. It's a lot of room, for the error. Then, after that, each one 4%. So total, 4 by 4, 16%. The question. So for the quiz questions, so I use Canvas quiz. So you may use that before, right? So I use the Canvas quiz. And here, so automatic grading. But you only have 1 attempt. I only give you 1 attempt. Okay? All right. Each quiz, I give you about 1 week to complete it. 1 week to complete it. Okay? At least 1 week. Can only be a little more than 1 week, but not less than 1 week. Okay? And quiz questions, the Canvas quiz questions, multiple choice, true and false, short answer. 3 types questions. Okay? All right. No time limit before the deadline. Because I do not set 1 hour time limit. No. So no time limit before the deadline. So you can work anytime before the deadline. Okay? So usually the purpose, I like you to use the quiz to help you study the notes materials. Because you need to go back and forth, study and work on some questions, then go back, study, No pressure, Just don't forget the deadline. Okay? Another thing, try to avoid, do not click the submit button by accident. That sometimes it happens. Okay? Yeah, right. Oh. But not for in-person class, right? Exam you are doing here, so no such thing. In my class, if that happened, I will give you a second chance.
You did let me go back.
Oh.
You did let me do it a little bit, but there was one.
Yeah.
There was one on my early math exam last.
All right, So, all right. Regarding the number of questions, I will delay a little bit after I finish homework. So then I, put together, because there is some new way I try to handle the quiz questions, homework questions. This semester I try to adopt a new way to deliver those questions. But after I finish homework assignment, then I talk about that new way. Okay. The first time I try this semester, all right, so that's the quiz part. All right. So here, the number of questions, I put a question mark on the number of questions. But later I will let you know. Okay? All right. Homework assignments. Only two assignments. Yeah. Each one 12%. 2 times 12, 24%. So adding together, you can see 40%. But we have project, we have tests. The remaining 60%. Yeah. So here, 40%. Yeah. 2 assignments, not too many. 1 for midterm test. Practice, prepare yourselves for the midterm. Another for the final. Okay? Each one, 25 questions. Each one, 25 questions. Okay? Yeah. All right. Some of the question, pretty challenging. Pretty challenging. You need to spend a lot of time. Pretty tricky. Yeah. 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 Have some fun. Yeah. All right. All right. Yeah. So now, let me give you the idea. Something new I want to practice this semester. Yeah. All right. Based on my experience in the previous few semesters, some students complain about, too much work, especially near the deadline. Yeah. Too much work, always asking for extension. Okay? Extension, another extension, and so on. Okay? Yeah. Because some students, they always do the assignment the last day, the deadline, the same day of that deadline. Yeah, that's not good. Because the assignment is so hard. How can you do it in one day? Right? So hard. So then, extension, sometime last semester I gave 2 days extension. Okay? Yeah. But the result won't be good. Yeah. All right. So this semester I try to take a new way, try to spread the workload. Because if I put too much workload, for example, 1 quiz, 1 home assignment at the same time, because sometimes you may have overlap, right? 1 quiz, okay, yeah, running. Also, you need to, at the same time, work on 1 assignment. You may have too much work, right? Yeah. So this semester I have a new idea. Spread the workload to a long period of time. Yeah. Then, when you work on these assignments, you won't have that much work in a short period of time. Yeah. So what's the idea? Let me describe here. Yeah. I will use practice exercise question sets to let you do practice. Yeah. So here I call it exercise question sets. Okay. So what's that? Let me explain this idea, new idea. Yeah. Because this course is a harder course, relatively, harder than other courses. Yeah. Most of the other courses, yeah, but not all. Yeah. Yeah. All right. So we need to use this idea. Yeah. After each class, I post 1 set of exercise questions covering the material of this class. Yeah. Except today's class. Today I won't post. because the first class. We won't have much material today. So no exercise for today. Yeah. But starting from next class, yeah. After the class, I will post one set of questions. Yeah. You know, check your understanding for that class. All right. Yeah. A list of questions. Here, I couldn't give you the exact number. Yeah. Could be more, could, long, short, Yeah. 1 or 2 pages, but not too many. Okay. Yeah. Yeah. Minimum 1 page, at the most 2 pages. Okay. Yeah. Not more than 2 pages. Yeah. Yeah. All right. Yeah. So what's for that? Those exercise questions for your study. When you study, so then you try to answer those questions. Okay? Yeah. And do some work, answer those questions, but keep your work. Okay? Yeah. Keep your work. Because you need to use it later. Don't throw away. Keep your work. Okay? Yeah. Then, I won't collect it. I won't grade it. They are not assignment. Okay? I won't collect. And I will not grade them. Okay? Because they are not assignments. Only for your self-study practice. Okay? All right. But later, actually, I will grade them in some way. Okay? Later, think about when we have our official assignment on quizzes and homework assignments, then I copied those questions to, quizzes or homework assignments. That idea. Okay? You keep your work, but when you work on the official assignments, you won't need that much time, right? Because that's the reason I ask you keep your work. You may need to, recall. Yeah, sometimes you may forget, right? You have some brilliant solution, but unfortunately, you forget the idea when you really need to put on your formal assignments. Yeah. Don't let that happen. Okay? Any good idea, nice explanation, write it. Yeah. Yeah. You do not turn in. You keep your work. Yeah. But when I make the quizzes, homework assignments, most of the questions, may not be all, most of the questions I will copy, move, and rearrange in our formal assignments. Yeah. But then I will give you a few more new questions, but small number of new questions. Yeah. The major part, all the questions, you already practiced, right? Yeah. Question.
Can we check if our answers are right?
No answer posted. Yeah. So for exercise, for this one, no answer posted. Okay? Yeah. No answers because, in the quizzes and homework assignments, at that time, quizzes, Canvas will do grading. This one, I will do grading. Okay? I will do grading. But in reviews, definitely all the answers should be given. Okay? In review session, before the tests, all the answers should be given. Okay? Yeah. Question.
So you're saying like next class, you'll be posting exercise questions
Yeah.
on Canvas. Like this, we got Monday, and then Tuesday, Wednesday's our next meeting. So if we work on the exercise questions, and then come in on Wednesday, can we ask you like, hey, I was curious about this question. Is this the correct operation or is this the correct thought process?
Uh-huh.
Is that what we get?
Yes. You can ask me questions. I can answer your questions. But usually I cannot tell you the answer correct or not. But I just explain, you need to do this, think this way, that way. Yeah. Give you instructions to answer the questions, but no answers, yeah. Just some helpful information to answer the questions. Yeah. But I try my best to avoid giving you the answers. All right? Yeah. Definitely. Yeah. So you can ask me in class. Yeah. That's the new idea I try to practice this semester. One new idea. I have another one. You will see later. Yeah. 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 All right. So any questions? Yeah. So that's this first part. Oh, I try to control the time because I don't want to spend too much time on the syllabus. I have another important topic I want to talk about. Yeah. Because in my previous class, the whole class I spent on syllabus. Yeah. So here I want to use 1/2 of the class. All right. Next. Then, programming project. 2 programming projects. Yeah. So usually I allow you to use 3 major programming languages. Yeah. One C, C++, another Python, the third one Java. So usually these 3 programming languages. Yeah. All right? Yeah. Yeah. And amount of time, at least 4 weeks. So each project, I give you at least 4 weeks. Yeah. Yeah. Could be longer than that. Yeah, but greater or equal to 4 weeks. So you should have plenty of time to complete it. Okay? Yeah. Yeah. And I may give you an optional task to earn some extra credit. Okay? Optional task to earn some extra credit. Yeah. Yeah. All right. So each one 14%, total 28%. Yeah. Oh, one thing I have to let you know this semester, actually every semester, some students, they copy the code from other students. Yeah. So I can find it. Yeah. Yeah. So I compare the source code. Okay? I compare the source code. Yeah. Yeah. Don't do it. Yeah. Write your code independently. Okay? Although you can discuss the idea, but when you write the code, write it by yourself. Okay? Exchange idea, that's fine. Right? Yeah. I allow you to. Yes. So that's fine, no problem. But you write the implementation code. Do it. Do your own way. Do your own way. Okay? Yeah. Yeah. All right. Yeah. 2 tests. 30%. Yeah. Yeah. Here you can see. Yeah, because here, this is in-person class. In parallel, I have an online class. For the online class, the lectures, I just use the recorded video that I post for my online class. Okay, yeah. But when I run tests, so I want to even the playground. Yeah. I try to even the playground a little bit. Yeah. All right. So here you can see in the midterm, I give you the date. March the 13th, Wednesday. So that part, you do it here. Yeah. 75 minutes, you do it here. 20 basic questions. Okay? 20 basic questions. 75 minutes in class. You complete it. But after the class, you still have 5 challenging questions. Because you need more time. So I let you do those 5 challenging questions at home using more time. Okay? Yeah. So here you can see from March 13th, Wednesday, the due date, March 16th, Saturday. So you have more than 3 days. Okay? Yeah. 5 challenging questions. Okay? Give you more time. All right. 20 basic questions, you don't need that much time. Yeah, so you can complete it in 75 minutes here. Okay? Yeah. Yeah. But you need to be familiar with our course materials. And when you do the test, I allow you use all of our course materials. Open book, open notes. You can use your computers, laptop, to access our course materials. Homework assignments, all the quiz questions, answers, yeah. Use your computers, allowed, yeah. But when you use your computers, 2 things you cannot do. Use computers. Yeah. No search engine. You cannot find an answer using the search engine. Okay? Yeah. So make sure don't do it. Yeah. All right. Second, do not use any communication software to send your answers to other students. Yeah. These 2 things not allowed. Other than that, use our electronic materials. Yeah. Legal, another thing, using calculators. Okay? Sometimes some online calculators allowed. Okay? Yeah. Yeah. So because we have a lot of computation questions, so you may need to use calculators. So you can use your computer, to use some, Wolfram Alpha, for example, yeah, you can use to do your calculation. Okay? Yeah. All right. So any questions? Yeah.
Are any online calculators not allowed? Websites we should avoid?
I do not have an idea, but I recommend Wolfram Alpha. Okay? Yeah. I recommend Wolfram Alpha. I always use that. Yeah. For other, avoid, I don't know. So you may talk about ChatGPT, things like that, some AI tools. Yes. Yeah. Yeah, do not use the AI-based tools. Yeah. Yeah. Wolfram Alpha. Yeah. Yeah, but I don't know if there is AI in Wolfram Alpha. Yeah. 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 When I see it, then I will stop it. But before I see it, so you can use Wolfram Alpha. Yeah. All right. Then another thing, attendance, 2%. So every time before the class, I'll call. I missed your name, Ali, right? So you came a few minutes later. Yeah. So after the class, I will check your name, attendance. Yeah. All right. So that we have only 1 student not here today. this attendance 2%. So I check every time, so at the end, I will have the statistics data. So each student, I have a percentage, telling me showing up or not. Yeah. Yeah. But I want to use one line for this class. Let me see. This class. Yeah. This class, still 80% line. Okay. So if you can get your overall average above 80%, then you automatically earn this 2% automatically. Okay? No matter that percentage attendance number. Yeah. If below 80%, then I use that percentage number. Okay? Yeah. To multiply this 2%. Above, so then I think you study well, right? And you study basically all the materials. So that I treat you as attend our lectures regularly. Okay? Yep. Yeah. For many students, that's not easy. Yeah. So I want to use that 80% line. Yeah. But if you study, if you really spend time follow the lectures, that's not hard, 80%. That's not hard. Okay? Based on my experience. Yeah. All right. That's what I like to talk about for the syllabus. Yeah. Before we move to the next topic, any other questions? Syllabus? No? Oh, one thing. Yeah, some special thing I may like to do. For our homework assignments. Yeah. So usually I do this for hard assignments, but for this class, all homework assignments we can treat as hard assignments. So for hard assignments, I give 1 day grace period. Okay? Yeah? Yeah. So no penalty if you submit it less than 24 hours after the deadline. Okay, no penalty. Yeah. After more than 24 hours, penalty 4 points per day. Okay. After that grace period, okay, 4 points penalty per day. Okay? Yeah. So I accept late submission, but be careful. If I post the answers, then I won't accept. Okay? Yeah. Before I post the answers, yeah, that 4 points per day penalty. After I post answers, I do not accept late submission. Yeah. Usually, you have a few days, yeah, at least, yeah, several days, yeah. But not too long. Yeah. Too long, so after, because think about, we need to prepare for the midterm. So I need to post the answers quickly when I do review, right? I need to do a review session for the midterm. At that time, I need to post all the answers, all the quiz answers and the homework answers. Quiz answers, I want to set. So when you do the quiz, I haven't told you the number of questions in the quiz, right? Yeah. So here, number of questions. So I may like to, yeah, because this way, think about each module, we have 4 parts. 4 parts. Okay? Yeah, 4 parts. Yeah. So when we practice, so usually I may give you 5 questions each part. But we have 4 parts each module. Yeah. So you will see 20 questions each module. Okay? Yeah. So you can see each quiz, you expect to have 20 questions. Yeah. So I just copy those, 5 questions for 4 parts, put it together for a quiz. Or if you look at the 20 questions in the quiz, that's a lot. Yeah. But you already have them, right? Yes. So you won't feel too much work to do, okay, in that way, because you're spread out. You already finished the work, okay? Yeah. So let's try this way this semester. All right, yeah. All right? Yeah. Any other questions? Yeah, let me try to recall. Yeah. So if there are any important points I didn't talk about here. All right. Yeah. All right. Yeah. Later, if I see something important, then I will let you know. Yeah. So let me. Oh, yeah. Final, we use the similar way. Okay. Final. Still. Oh, yeah. Yeah. I need to talk about a little. Yeah. Let me use a few more minutes to talk about the final, because you always want to know if the final is comprehensive or not, right? Yeah, that's important. Yeah. So I want to say it's in a special way comprehensive. It's comprehensive, but not completely comprehensive. Yeah, special way. So what kind of special way? So the questions I put before the midterm, I will put a few questions before the midterm, but those questions in the midterm, after I grade your midterm papers, if I see a few questions, you have a lot of errors, then only those questions you have a lot of errors. So I repeat it in the final. Okay? So if you do a pretty good job, then we won't do it. Okay? Only focus on a few questions. Most of you didn't do well in the midterm. Yeah. But I'll let you know what are those questions. So when you do preparation, focus on those selected questions. Yeah. That kind of comprehensive, yeah, but not a real comprehensive. Yeah. All right. Yeah. So there's still 2 parts. The first part, you need to do it here. You need to do it here in 2 hours. Huh? In 2 hours. Yeah. Here I didn't give you the time, right? Yeah, because the final time could be different. Oh. Yeah, the final time. Yeah. So I need to update the syllabus because I need to specify what 2-hour slot, the specific 2-hour slot, close to this time, but may not be the same. So I need to double check. Even if it is the same, yeah, it's better I put it explicitly. Yeah. Because usually it's different. Usually it's different. Yeah. Then The challenging question, these 5, still very challenging. That very, reasonable challenging. Yeah. So you can do it at home. Yeah, you can do it. You have use more time to complete the challenging questions. Right? And this part, remember, because we treat it as the hard assignment, you have 1 day grace period. Okay? 1 day grace period. Yeah. So make sure you have plenty of time, to get the best grade you can have. Okay? All right? So that's what I want to explain in the syllabus. Yeah. All right. If no question, let us move to the next topic. Yeah. 8.1, basic procedure of problem solving. So in this class, basically we learn problem solving for real-world computing problems. So we will learn methods, strategies, techniques, thinking, principles, all those things to solve the real-world computing problems. All right. First one, in order to explain, the typical problem-solving procedure, how to think. Let me use this puzzle question, chessboard puzzle question. How many squares of different sizes can you find along the grid of a chessboard? Square of all different sizes. Yeah. For example, this is a square, right? 3 by 3. The size is 3 by 3. It's a square. Okay? The squares of all possible sizes. How do you count that number for this puzzle question? Yeah. Let's think about it. Not too hard. Yeah. But some basic ideas in problem solving. Yeah. Say something.
I think there's 7 different square sizes you can have. If there's a square, it has to be just as long on the top as well as the sides.
Right.
And you can only have, technically it's 8 if you want to have a single square. I guess that's
Yeah.
one, but I think
You count it one by one. You count it. Yeah.
I think it's 8 different squares.
Right. Regarding the sizes, we can easily see 8 different sizes. Right? Yeah. Yeah. All right. All right. Yeah. Now, here, I use this example to explain the typical procedure for problem solving. Yeah. When we treated this as a computing problem. Yeah. So when we solve a computing problem, we need to do data processing, work on the data. So what's the data we have here? Yeah. We're given data. Yeah. This chessboard, all the information you can see here on this chessboard, we treat it as data. Okay? We can define it this way. The squares of all sizes, that's our data. So we study our data, we process, we manipulate our data here. Okay? So we can move around the data because we can, we control our data. So we can move around the data. All right? Yeah. Data manipulation. Yeah. The given data, squares in all different sizes. Yeah. We know 8 different sizes. That's our data. Okay? All right. Next question, how to identify all the squares. Yeah. We need to identify, yeah. Keep track of all the squares. Okay? How to keep track of all the squares? Okay? Yeah? Right? Yeah. For example, 1 by 1, it's easy, right? How to keep track of 2 by 2 squares? All 2 by 2 squares. How to keep track of them? Right? Do not miss anyone. Do not miss any 2.2 squares. Okay? Start from top left, the first 2 by 2, second 2 by 2, and the next one in order. Yeah. When we follow certain order, we won't miss any. Make sure we won't miss any. Okay? And so on. Until we hit the right bound. How many of them? One scan. One scan like that. How many 2 by 2 squares? From left to right. Can you see quickly? Count. 7. 7. Okay? 7. Not 8. 7. Can you keep track of it? How to get a 7? How to get a 7? All right? How to get a 7? Yeah. Try to find some way. All right. That's the horizontal scan. Right. How about vertical scan? Vertical. From top to bottom. How about a vertical scan? How about vertical? Oh, yeah. Yeah. I'll get lost. All right. Yeah. Vertical scan. All possible 2 by 2 squares vertically. Okay. How many? 7. Okay. Horizontal 7, vertical 7. How many total? Horizontal 7, 49. 7 by 7, 49. Okay? Yeah. All right. 2 by 2, that's particular size. Total 49. Okay? Yeah. All right. All right. All right. Yeah. So to identify a square, we use 2 vertical lines and 2 horizontal lines with the same gap, right? Yeah, same difference, same distance between. Okay, same distance between. That's how we define one square. Okay, yeah. Only use the grid lines. Okay, only use the grid lines. Okay. With the same gap, horizontal gap, vertical gap, the same, then we can define one square. Okay? Yeah. All right. Now, here you can see we do some experiments. What do we just did? 2 by 2, horizontal, vertical. That's our experiment on data. So we work on our data. We do experiments for some special cases. In our real-world problem solving, we always do in that way. Do experiments. Okay? Yeah. After the experiments, we understand our data better. Do you feel you understand the data better after this, 49 2 by 2 squares? You feel you understand a little better? Yeah. All right. Then, next, we want to look at our data in all different sizes. Yeah. The critical step this time. When we get more experience, when we have observation for more properties of the data, understand better so we can see more properties of the data, then hopefully we can make some critical step. We can, get insight. If we can see the insight of this problem, we are very close to the solution. Yeah. All right. How to manipulate the data efficiently. So this time, there is another important point in problem solving, computing problem solving. That's when we manipulate our data, one thing we need to do frequently, that's organize our data. Make our data well organized. That's an important step. Yeah. In this example, we need to organize our data. If you do not organize the data, the squares of all sizes, it's quite messy, right? The data with all different squares, spread everywhere, quite messy. Not well organized. Yeah. All right. Arrange the data in a well organized way. That's an important step in problem solving. Organize the data in a well organized way. Yeah. The reason is very simple. Yeah. Based on your everyday life, when you organize your stuff, well organized where you can find things easily, right? Yeah. Here, we can find our data easily. Yeah. Because sometimes we need to search our data with the special properties. If it's well organized, then we can find our required data quickly. Otherwise, too messy. How to find the required data piece, right? Yeah, it's hard. Yeah. Takes a lot of time to find, then your algorithm will be very slow. So one important data is organize your data. Yeah. Here, how do we organize our data?
Width and length of each square that we're making, so like a 1 by 1, 2 by 2.
Yes. Based on the data sizes.
Because we got a balance of 18 maximum. So
Yeah.
we know we can never get over.
Yes. Yes. Yeah. So here we characterize our data. We allocate our data into different categories. Category 1, 2, 3, 4, 5. 1 by 1, one category. 2 by 2, second category, and so on. Okay? So we organize our data in these 8 different categories. That's the way we organize our data. Okay? Yeah. All right. Characterize the data in suitable categories. Suitable here, this question, by sizes. Yeah. So that the data in the same category shares the same property. Yeah. Same category. When we do the counting, it's very easy, right? If you count from different categories, then it's hard to count. But same category, easy to count, right? Yeah. So you can see the benefit. After we characterize our data, you can see the benefit quickly because we can apply some formula. Okay? 7 by 7, that formula, we can use it. Otherwise, you cannot use any formula, right? So if you do not put in these 8 categories, which formula you can use? Yeah. Hard to imagine. Too messy. Okay? Yeah. So you can see the benefit immediately. What are the categories, sizes of squares? These 8 sizes. Yep. Okay. All right. Then, next step, our main work. Let's do the main work. Okay. How to do the counting. This time we need to do the real work, the counting work. In discrete math, you learn some basic counting techniques, right? Yeah. The product rule, the sum rule, right? Yeah, those basic things. Yeah. So we need to use basic counting methods here. Yeah. All right. Squares in various sizes. Yeah. The size, yeah. So let's look at it one by one. First size, 1 by 1 size, how many such squares? Formula, yeah, 64, yeah. So let's use 8 by 8, how about that? Horizontal, vertical, 8 by 8. Yeah, although it's 64, yeah. So let's use this form, yeah. Because we want to write a final formula. Okay, yeah. 2 by 2, 7 by 7. How about 3 by 3? Good. So you can see, after some experiments, you get the rule. Do you need to draw 3 by 3, horizontal, vertical? You may not need that, right? That's the reason we do a few experiments, because you can see some rules after a few experiments. So, yeah, because you do not need to do the things for all the different sizes. Yeah? Because you observe some special rule you can apply everywhere. Okay? Yeah? Yeah. All right. Then, the final answer, just add these numbers up. Add up all these numbers. You get an answer. Okay? All right. Observe a rule. Yeah, here, after this here, that's how we manipulate our data. Okay? So we organize, so we generate some results, some intermediate result, final result. Before we get a final result, we have some intermediate results. Yeah. Here, intermediate result. Subtotal, intermediate results. Yeah. All right. All right. Here, can you see some interesting rule between size and the number of squares? Observe some interesting rule. You have seen it. Yeah. You have seen it. Yeah. Here, I want to put it here. Okay? Do the summary. Yeah. Put it in right here. Yeah. Suppose the size, yeah, because here we want to use some general abstract expression to represent all the sizes, m by n. Yeah. Yeah. When we solve real-world problems, many times we need to do abstractions, right? Yeah. We need abstractions. Yeah. So we treat ourselves, we as problem solvers. Yeah. So we want to do some advanced work. In order to do some advanced work, our human brain, we have one special ability, that's the abstraction. Our human brain, we have that ability, abstraction. Here we do abstraction here. M by N represent sizes, all possible sizes. One expression represents all sizes. That's the efficiency of abstraction. Okay, all right. Similarly, for the number of squares, we want to use another abstract representation, general representation, n by n. Okay? Can you tell me what is the relationship between m and n?
Is it assuming the chessboard, you go to 8 by 8 would be 9 minus the m equals n squared?
All right. You only need to give me relationship between m and n. Don't worry about the square. Okay? Forget about the square. Just we want to know relation between the m value and n value. Yeah, forget about the square. M and n. What's the specific relationship between m and n? You can see the data. M. Question, answer.
As the size increases, the number of squares increases.
Give me the relation directly. Do not use words, sentences. Just give me the formula. Give me the formula.
Is it not 9 minus m equals n?
Yeah. Yeah. And yeah, you use minus, the same thing. Here, let's add up. M plus n equals 9. How about that? Simple equation, right? Simple identity, equality. Simple equality. And it's true everywhere, right? Think about it. So we treat this as a rule. This rule holds everywhere in the chessboard. Everywhere. Okay? Yeah. Is this property some nice property? Can we treat it as some nice, interesting property? Yeah. So here you see something in problem solving, very useful, nice property. Yeah. Because when you change your size m and the number n, this 9 never changes. It's a fixed number. When you scan your data everywhere. Scan your data everywhere. So this property, the sum equals 9, never changes. Is that interesting? Is that some interesting property that we like to pay attention? Yeah. So this gives us an important concept. It's called invariance concept. Here, we get the insight of this problem. The key property, critical, important property of this question, the insight, invariance. Thus 9 never changes. Invariance property. If you can find invariance of one particular problem, then you can use that invariance property to help you solve the problem. Think about that. Okay? Think about that. Yeah. All right. Yeah. So I only have 10 minutes left before the end of this class. Yeah. So I introduced this invariance concept. This is an advanced concept. Okay? Important, advanced. Yeah. Not easy to find. Given a question, how can you find an invariance? Yeah. Sometimes you can find, sometimes you cannot find. Yeah. All right. So here. This number does not depend on the sizes of the squares. Yeah. So here you can see, if we know that this invariance, this number, we can keep track of our data, right? We can keep track of our data. Think about it. Keep track of the data. All right? Yeah. Here, let me extend this question a little bit. Suppose we have a 100 by 100 chessboard. 100 by 100, same structure. Yeah. Same structure, but this time the size I increased to 100 by 100. Okay? then the size number n plus the, the number of squares, but the one dimension of that number of squares, and n plus n, what's that number? 101, 101, not 101, okay? All right, so then you get the rule, n plus n, this time, in that new question, so here, 100 by 100 chessboard, okay? So then our rule becomes equals 101. I said one important usage of this invariance, this property, is we can keep track of our data. Now, let's apply it, okay? In 100 by 100 chessboard, very large, I want to ask you, how many squares with the size 37 by 37?
So would you just take, because you want the size, so we know that n is 37, and we know our invariance number is 101, so we just take 101 minus 37?
M 37, not n. M, size 37 by 37. Sizes. We look at the size. 37 by 37 as the size. Now I want to ask you, how many such squares in that 100 by 100 huge chessboard? Do not give me the final answer, just give me the formula. What by what? That n. 64 by 64. Not necessarily the final answer. Formula expressions, also good. Also good, because we can see how you get it, right? If you give me the final answer, I don't know how you get that number. If you tell me 64 squares, I know you do it in this way. Okay? Now you can see the importance of this concept, right? Invariance. You can solve problem in a more efficient way, right? You can avoid drawing, how can you draw 100 by 100? Yes, you need to buy a lot of paper. It's too hard, right? All right, let me keep track of my time. So this concept, invariance concept, how important it is. Okay. Not easy, it's hard, but it's so important. All right, okay, Understand the role of the importance. I want to give you a summary here. After we, now we don't worry about the answer. So you just add up those numbers, you get the answer, right? So we don't have to complete that. Everyone can do that easily. So let's move to the summary of this whole solution. What we can learn from this solution. Okay. All right. The invariance usually provides a critical property or insight of a problem. Okay? For some problems we don't need, only for some special problems we need this invariance property. For many other problems we don't need. But you may not, so here the hard part is, you may not be aware of it. Given a question, how do you know? You need to find invariance of, in this question. You do not know it. All right. This invariance property can help us keep track of the data. You ready? You saw it? Keep track of the data, right? So here I use this example, all right? So we just did it. Okay. Usually, it is not easy to find invariance of a problem. That's the hardest part. After you find that invariance, then the remaining work, much easier. Much easier. Okay? All right. Then complete the computation work. Here, one step. So we can quickly finish it, complete the computation work. Yeah. Expression for the number of squares, we can write in this way. These 8 consecutive square numbers adding together. Okay? Yeah. Yeah. So although you can do the calculation in this way, yeah. All right. Yeah. Here, if we consider n by n chessboard, yeah, we extend this question to n by n chessboard. Yeah. Or we may not call chessboard, just a name, whatever you like to call. Yeah. Grid. Okay? Yeah. All right. Then, if I ask you to find the squares in all the sizes in n by n chessboard, can you write it, formula for it? All number of squares in that n by n chessboard. Okay? Yeah. Do you want to write this formula? Right? That formula? Yeah. And we can, we have an explicit formula for this summation. Square summation, explicit formula. This one. Okay? Yeah. Yeah. You may find it in your discrete math. In your discrete math, you may find it, this formula. Okay? Yeah. All right. Then, only 2 minutes left. Let me finish it. Then, give you another chess puzzle question for practice. Chess puzzle. Yeah. Interesting chess puzzle question. Yeah. Given a chessboard like this, given a chessboard like this, but I cut off 2 squares, one at top left corner, another at the bottom right corner. I cut off 2 squares. Okay? Yeah. Then I use the domino cards. Look at this. This is a typical domino card, right? Yeah. Suppose you have many domino cards. Now I ask you to cover this, 2 missing corner chessboard. Can you use certain number of domino cards to cover this chessboard without overlap? Without overlap, yeah. But you cannot cover in this way, okay? Yeah. Yeah. So you have to, put all the domino cards within the bound of this chessboard, okay? Yeah. Can you get a perfect coverage? Yeah. This question, okay? Yeah. 31 domino cards. Can you use 31 domino cards to cover it? Yeah. Possible or not? Right? It looks possible, yeah. Because you only have 62 unit squares. 62 unit squares. So it seems possible using 31 domino cards to cover it. Yeah. Yeah. But there is the shape consideration, right? Yeah. Here, you only do the area consideration. Here, when you see the possibility, you use the area consideration. But you also need to use the shape consideration. That could be different. That could be different. Yeah. But the reason I give you this question, the hint, try to find some invariance. We practice that invariance. Finding invariance. It's hard, but if you can find it, you're almost there. You're almost there. Now, think about this interesting puzzle question. Interesting puzzle question. Okay? Yeah. Before we end this class, I show you one more thing. Remember, I mentioned another new idea this semester, I want to show you that new idea. Okay? Yeah. All right. This semester, I will make many flashcards like this. Yeah. Summarize all the knowledge points in the flashcards. So for this part A, I summarized 3 flashcards. This is the first one. Okay? You see it, the reference M1A, page 7. Module 1, part A, page 7. You can find it. Yeah. Second flashcard, you can find it MA1A, page 8. Third one, that one. Okay? I summarize. Part A, you have 3. Okay? So I will give you all my flashcards. When you study, so you can use that, flashcards. Yeah. For Module 1, I summarize, I have almost 50, that many. Only for Module 1. 50 flashcards. Okay? Yeah. So, oh yeah, for module. Only Module 1, 50 cards. Yeah? Think about that. Okay? All right. That's it. That's it.